Hello everyone, welcome back to ECE111 classes. As we have discussed in our last class about superposition theorem, so we are going to continue our discussion with superposition theorem when we'll solve the circuits where we have dependent sources. So the objective of our today's class is, we will be solving numericals containing both dependent and independent sources, and we will be applying superposition theorem to solve the circuit. So let us consider this numerical as we have seen here, which contains two independent sources and one dependent source. So let us redraw the circuit again. So as we have two independent sources and we have, as per our superposition theorem, we have to remove the sources and consider one source at a time. So let us consider a first circuit. In the first circuit we are considering 30 ampere source, and in the second circuit we are considering the 20 volt source. So as we remember how to replace the voltage sources, we have the ideal voltage sources are replaced by their internal resistance, which is considered to be as 0, that means short circuit, and for ideal current sources we replace them by open circuit. So now consider in circuit 1. So now here we have to determine the current Ix, that means the current flowing in this branch. So to get the current flowing in this branch, so let us consider also we have a dependent source, the value of which is 4Ix. So we have to determine the value of Ix. So let's see the value of Ix. Suppose we are naming it as Ix1, this as Ix2. So this will be correspondingly Ix1 and Ix2. Okay, so this Ix1 will be equals to, if we consider this voltage drop to be V1, then it will be V1 divided by 5, and as we know we consider the directions moving out, so the direction of current Ix1 is in the opposite direction, so it will be negative. So now applying KCL at node 1, KCL at node 1, circuit 1. So what we have, so in this direction we have minus Ix1, then we have plus, this is in same direction, so it will be 30, then plus this will be V1 minus 4Ix1 divided by 1. Okay, so now here putting the value of Ix, so we'll get the value of, or other way around we require the value of Ix1, so let's put the value of V1, that means V1 will be 5Ix1 negative, so we can put this here, and the value of Ix1 can be calculated, and it will come out to be as 3 ampere after solving. So in the same direction whichever we are considering. Now the first circuit value is 3 ampere. In the next circuit, let us see. As you can see, this is a simple closed loop, and in this we can apply mesh analysis. It means applying KVL, in circuit 2. So what we have, 20 minus 5 Ix2 minus 1 into Ix2 minus 4Ix2 equals to 0. Okay, so from here we get the value of Ix2, and it will be coming out as 2 ampere in the same direction. So now as per superposition theorem, we know value of the response in any branch is equals to the algebraic sum of the individual responses considering one source at a time. So it will be 3 plus 2 equals to 5 ampere in the same direction, because both are in the same direction, so it will be plus. Okay, so this is how we can solve a numerical containing a dependent source. So now let us see what the simulation will say. So as we can see here, it is the same circuit where we have 20 volt, we have 30 ampere, and this is the dependent source as we have obtained so you can verify it here. So this is the current dependent voltage source. So we are putting it like this. So let us simulate this and see what is the value of the response that we get. So in the first circuit, you can see, considering the full circuit, we are getting it as 5 ampere. Then considering the next circuit where we are considering only 20 volt, so there we are getting it as 2 ampere as we have obtained. Then in the third circuit, we are considering only the current source, and let us see what is the response. So it is 3 ampere. So total is 2 plus 3, 5 ampere. Okay. So we have verified the same numerical using simulation also. Okay. So let us quickly consider another example. So let's see this, how we can solve this example. So here also we have two sources and one dependent source. So first let us redraw the circuit. Okay, so after redrawing and considering one source at a time, in the first source we are having the 2 ampere current removing the 5 volt, and in the second circuit we have 5 volt removing the 2 ampere current. So now let us see what we will get after solving these two. So in the first circuit we have let us name it. So we have to determine the current I1, that means this current. So here this will be, suppose, I1. Okay, let us name it as I1 and I2. Let us consider the current, the overall current is I. Okay, so the value of, as per nodal analysis, we already know the current moves in the outward direction. So the value of I1 will be minus of Vx by 10, right? So now applying KCL at node X. So we have, so this is Vx by 10 plus, this is in the opposite direction, so minus 2, then it will be plus Vx minus 4Vx divided by 2 equals to 0. Okay, so now here we can put the yes, so we can determine the value of Vx from here, so which after solving will come out to be 10 divided by 7 volt. So the value of I1 will be, as we have already determined, it is Vx divided by 10, so it will be 1 by 7. So this is also minus, this is also minus, so minus plus it will be plus, so 1 by 7 ampere, which is 1428 ampere in the same direction. Okay, now let us consider the second case. So in the second case, so let me take another ink. Okay, so now here what we have a complete loop. So in that loop what we have is the value of current I2, the voltage Vx will be 5 minus 10 times of I2, right? So the voltage drop across this point will be nothing but this drop minus this voltage drop minus this voltage drop. Now applying KVL in loop, let us, you can name it as A, B, C, D. So A, B, C, D, A. So what we have, 5 minus 10 times of I2, then minus 4Vx, and then minus 2 times of I2 equals to 0. So after putting the value of Vx here and solving, we'll get the value of I2, which will come out to be 1528, which is given by 0.53 5 ampere in the same direction. So the main current I1 will be the algebraic sum, so it will be 0.1428 plus 0.535, which will be equals to 0.678 ampere in the same direction. Okay, so this is the current after applying superposition theorem. We have obtained this current. So let us see what is there in the simulation. So this is the same circuit that we have drawn here. As you can see, 10 ampere, 10 ohm, 5 volt, 2 ampere. Then we have this dependent source, which is dependent on voltage. This is the voltage dependency, and we can see the value of your constant, your multiplier is 4. Then we have 2 ohm. So after solving, what we have here is 0.678 is the original current. In the first one we are getting 142.86, and the second one we are getting 535.71. So that is what we have obtained here, right? So the first one is 1428, so this is 1428, and the second one is 535, so this is 535. Okay, and the total is, after combining this, the same as 67857. So we obtain here 678, right? So it is verified, whatever we have done is correct. So like this we can solve any numerical containing dependent source using superposition theorem. So I hope you have learned your ideas how to use superposition theorem for solving dependent sources. Now one very common thing or common mistake that many of us used to do while considering superposition theorem, the main thing that we have to consider here is, whenever we have a voltage source, we always replace it by a short circuit. Whenever we have a current source, we always replace it by an open circuit. So this is the basic logic. And suppose your value is given as, suppose 5, we have a voltage source 5 volt comma 2 ohm. Okay, so this means the internal resistance is 2 ohm. So whenever we are replacing this, now we are not going to consider a short circuit, we are going to consider a 2 ohm resistor. Okay, so this is a very basic thing that we should follow, so that we do not make any mistakes. So thank you for joining. We'll see you again in our next class. Thank you.